Let's jump right into this explainer, where we're unpacking a highly critical, fully established capability from the energetic paradigm. We call it proof discipline. Look, if you spend any time around modern AI, you already know it can talk. I mean, it generates these beautiful, flowing sentences in a matter of seconds. But there's a massive and frankly often dangerous gap between an AI that talks smoothly and one you can actually trust in a high-stakes environment. Today, we're going to see how EP bridges that gap. We'll look at a concrete operating function that takes the known weakness of AI hallucination and flips it into a strictly auditable, highly investable capability. We've got a tight roadmap for this one. We're going to move systematically through the limits of persuasion, dive into the actual proof discipline framework, and then unpack the three core pillars of EP's investment traction. Those are demand, execution, and scalability.
To get started, we really have to shatter this widespread illusion that just because an AI output is fluent, it must be factually accurate. Persuasion, as we know, is absolutely not proof.
And that brings up what is literally the million-dollar question. How do we stop fluent AI claims from turning into dangerous slogans? Because ordinary AI generates these persuasive claims effortlessly. It strings words together based on probability, right? So it sounds incredibly confident, even when it's entirely wrong. Now, if you're just building a chatbot to give you pancake recipes, that loose reasoning is totally fine. But in serious environments, we're talking investor due diligence, enterprise strategy, legal contracts. In those spaces, a claim has to survive intense scrutiny. You simply cannot afford for your AI decision support system to hand you a fluent, dangerous slogan disguised as a fact.
So, there's a stark contrast here. On one side, you have ordinary AI. It gives you persuasive text, sure, but the reasoning is loose. And worst of all, its failures are completely hidden inside that beautiful language. On the flip side, you have EP's proof discipline. This delivers output that is structurally reliable. The reasoning is 100% inspectable, and if a failure does happen, it isn't hidden away, it gets actively classified. It really comes down to the difference between just hoping your AI is right and actually proving that it is. Okay, so how do we operationalize this? Let's dig into the proof discipline framework itself.
First off, let's be crystal clear about what proof discipline actually is. It is not some abstract philosophical debate about truth, and it's definitely not just a glorified spell checker or cosmetic content editing tool. It's a concrete, active operating function. It literally controls the work. It changes how a task is framed before the answer is even produced, it checks the work while it's being generated, and it judges the final output. Instead of asking, hey, does this sound plausible? It asks, does this hit the required structure?
And here is exactly what that structural proof looks like in practice. EP requires every single important claim to pass through a really strict 7-part proof gate. First, the assertion, what is actually being stated. Then the mechanism, why does it logically follow? Next is the evidence, what data actually supports this. Then we define the boundary, where does this claim safely apply? After that, the limit, what stops the AI from overclaiming? Then the specific failure mode, what would break this claim? And finally, the consequence. What happens if the claim is just flat out wrong? Forcing claims through this specific filter makes it structurally impossible for them to slip by as unsupported slogans.
Now, let's pivot to the first pillar of our investment traction, which is demand. Why does the market urgently need this level of structural reliability? Well, there's a great saying for this. Demand appears when a repeated failure becomes expensive. And that cuts right to the economic reality of AI today. The repeated failure of ordinary AI is its habit of churning out those unsupported, persuasive claims we just talked about. And as AI moves out of the lab and into serious, heavy-lifting enterprise work, the cost of uncontrolled, fluent hallucination is just skyrocketing. Just think about the actual costs across different high-stakes sectors. In legal review, an AI hallucination isn't just a typo, it is severe liability. In financial analysis, a loose piece of reasoning translates directly into capital cost. In enterprise governance, it means operational failure. And for autonomous agents acting on behalf of a company, a bad claim creates massive reputational risk. The big takeaway here is that institutions absolutely do not need more persuasive text. What they desperately need are outputs that can be trusted, audited, corrected, and defended across all these critical environments. That is the core demand for proof discipline.
Which brings us to our second traction pillar, execution. Because having demand is one thing, but how do we execute this inspectable reasoning under pressure?
Execution isn't proven just by talking about how important a function is. It's proven when it actually operates reliably in real work. EP performs proof discipline through a relentless 3-step audit trail. Step 1, framing the task before production even begins, to define the required structure. Step 2,
actively checking the work during production against those 7 proof gates. And step 3, judging the final output strictly against that structure, totally ignoring its stylistic flair. It is a very active intervention at every single stage of generation.
And doing this creates incredibly concrete operational outcomes. The input gets transformed into a clear, manageable object of work. The reasoning path isn't hidden inside some black box of fluent language anymore. It's entirely exposed and inspectable. But here's the most vital part. Failures are classified to improve the very next execution. Think about it. When ordinary AI fails, a human editor just deletes the bad sentence, right? But when EP's proof discipline catches a failure, it categorizes it. Was it a boundary failure, a lack of evidence? That categorized failure gets fed straight back into the system to improve it. And that is what real execution traction looks like.
Next up, let's look at our third pillar, scalability. We need to see how this single capability expands without losing any of its control.
Scalability in AI usually just means throwing the exact same raw model at every new problem, which honestly just leads to chaos. For ECP, scalability means preserving that exact structural logic we've been talking about, but applying it across different domains and task pressures. So proof discipline scales out as repeatable modules. It becomes proof templates for investor memos. It becomes quality gates and checklists for technical reports. It forms the backbone of agent policies, governance workflows, and document intelligence. The surface-level content changes, but the core function, preventing those dangerous slogans, remains entirely intact.
And that leads us to a really vital insight. Scalable value comes from a repeatable mechanism, not from isolated consulting brilliance. You literally can't hire an army of human PhDs to check every single AI output forever. It just doesn't scale. If a function can be converted into templates, workflows, and software modules, which is exactly what proof discipline does within the energetic paradigm, then it has a clear, proven path toward productization. It proves that any domain using AI for complex work has to eventually rely on standard, repeatable proof structures if it wants to function safely.
Let's pull all of this together and look at the ultimate takeaway here. What makes this an investable EP capability?
It all comes down to those 3 pillars of traction we just walked through. Demand, proof. Discipline actively solves a massive market pain, which is the expensive, recurring failure of unsupported AI claims in high-stakes environments. Execution. It proves it can operate reliably under pressure, fundamentally transforming tasks and making reasoning fully inspectable. And scalability. It successfully converts this logic into repeatable, productized modules across a ton of diverse workflows. It's actively connecting a critical market problem directly to an executable method and a scalable product.
And ultimately, this is exactly why the energetic paradigm shouldn't be evaluated as just another set of content tools or, clever prompt engineering tricks. It really needs to be understood as an essential system of infrastructure. Proof discipline takes the recurring weakness of ordinary AI, its tendency to just persuade rather than actually prove, and converts it into a repeatable, highly investable capability. It makes AI work completely auditable, correctable, and most importantly, operationally safe for the enterprise.
Thank you for joining me for this explainer. As we wrap up today, I want to leave you with one final critical question to ask about your own systems. Will your next high-stakes AI outputs actually survive rigorous structural scrutiny? Or is it just another beautifully fluent slogan, quietly waiting to fail when it matters most? Something to think about. See you next time.